Assalamualaikum warahmatullahi wabarakatuh. Our group will present about introduction to roof construction on concrete. Okay, this is our group members, which consists of 8 members. And this is the contents in our slides. First of all, we're going to explain about reinforced concrete roof slabs, concrete slabs, membrane roofing, age of concrete roof slab, reinforced concrete roof forms, and then precast concrete roof system, bearing connection, additional bearing connection, and the last one is roof flashing. Okay, concrete roof construction is divided by two, which are reinforced concrete roof slabs and precast concrete roof systems. And my name is Zukrina, and I'm going to explain a bit about reinforced concrete roof slabs. Okay, form of a roof structure that use reinforced concrete slabs is flat roof. Okay, reinforced concrete roof slabs are formed and side cast in the same manner as concrete floor, which are one-way slab, one-way joist slab, two-way slab and beam, two-way waffle slab, two-way flat plate, and also two-way flat slab. Okay, roof slabs are normally covered with a type of membrane roofing. It may be supported by reinforced concrete columns, reinforced concrete frames, or bearing walls of reinforced concrete or masonry. Okay, reinforced concrete may be designed and cast into a variety of other forms, which are folded plates, domes, and also shell structures.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Nashafika binti Zamanuddin and I'm going to explain about two-way wafer slab. So the two-way wafer slab is the most technical and economical type of roofs among conventional system, and the main element that we are using for the two-way wafer slab is the wafer formwork. So it also made of reinforced concrete with concrete ribs running into two directions on its underside. Okay, we can see from two underside. Okay, from two directions. And it also preferred for spans greater than 40 feet, which is 12 meters, because they are much stronger than flat slabs with drop panels, two-way slabs, one-way slabs, and one-way joist slab. So this is the underside of a wafer slab, showing the grid-like structure. Okay, and this is the section of a wafer slab, including beam, ribs, and column head. So we can get the advantages and disadvantages of two-way wafer slab. Okay, so the advantages is better for building that require less vibration, and it has a bigger span, can be achieved with less material, more economical, and environmental friendly. So the pattern is also aesthetic. Okay, we can see it here. It's very aesthetic. Okay, and forms can be implemented with wood, concrete, or steel. So disadvantages that we get from using the two-way wafer slab is the quantities of formwork material that are needed is very high, and it can be, because of that, it is very cost, and it is preferred for flat topographical areas only, not for the slab areas. So next is the two-way flat plate. Okay, we can see at this picture, this is a two-way flat plate, and it's a concrete slab of uniform thickness reinforced in two or more directions, supported directly by columns. Okay, columns without beams. There are no beams at here or girders. And simplicity of forming and some flexibility in column placement make flat plates practical for apartment and hotel construction. So this is the two-way flat details. Okay. So this is the tensile reinforcement. Okay, at here. And here is the measurement. Okay, it must be 5 inches to 12 inches, 125 to 305 slab depth. And rule of thumb for slab depth is span over 30 feet. And it is suitable for light left to moderate loads of relatively short spans of 12 inches to 24 inches, which is 3.6 to 7 meters. Okay, it also should at column locations governs the thickness of a flat plate. Okay, so this is the two-way flat details, the pictures. Okay, next is the two-way flat slab. Okay, it is a reinforced concrete of roof construction in which a two-way flat plate is supported by columns, by columns with drop panels or column capitals. A flat slab is a flat plate thickened at its column. Here, it supports to increase its shear strength and moment resisting capacity. The load will be carried in both directions for two-way slabs. So this is the plan of the two-way flat slab. So this is the two-way flat slab steels. It is also for tensor reinforcement. Using the tensor reinforcement, and the measurement for this is 6 inches to 12 inches, which is 150 to 305 meters, typical of slab depth, and rule of thumb for slab depth is span over 36. So the draw panel is the portion of a flat slab taken around column, had to increase its resistance to punching shear. So we can see at here is the minimum projection of drop panel is 0.25 times slab thickness. So for this one is the minimum width of drop panel is 0.33 span. And at here is the column capital may be used in place of or in conjunction with a drop panel for increased shear resistance.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Kashrin binti Jamaluddin, and I'm going to present about the member roofing for both construction, reinforced concrete roof slabs, and for precast concrete roof system. So normally the roof slabs are covered with a type of member roofing, which is shown in this section. So the function of the roofing membrane is the waterproofing layer of the roof. So but first I'm going to explain a little bit about the flat roof assemblies. So it includes the BAARs. It protects the roofing from uplifting wind forces and mechanical abrasion. And then we have a roofing membrane, which is the waterproofing layer of the roof, rigid foam or lightweight concrete insulation for thermal insulation, vapor retarder, it's for impedes or blocking the passage of water vapor into the roofing assembly. And then we have smooth trowel finish to receive insulation and roofing. And the last level we have the concrete roof slabs, the reinforced or the precast. There are two major types of member roofing systems, which are built-up roofing systems and also single-ply roofing systems. For the built-up roofing, it uses a built-up roofing aggregate, or we can call it as lacquers applied of gravel, slag, or marble chips that aids in stiffening membrane and resisting wind blow-off. It also have a surfacing bitumen of coal tar or asphalt. And then we have the aggregate for the drainage layer. And then we have the roofing membrane, thermal insulation, vapor retarder, and then the last level for the concrete roof slab. So for the built-out roofing, precast concrete must have all joints that rooted. So any unevenness between the units must be level with a painted topping or fill, so it blocking or it's avoid the moisture or thermal insulation problem. And then we have the single ply roofing systems. It applied in liquid or sheet form. So one of the example of sheet form is it uses thermoplastic membranes, PVC, which is polyvinyl chloride, or polymer modified bitumens, or EPDM, which is ethylene propylene monomer, So there will be three types of single-ply roofing systems, which is fully adhered system, mechanically fastened, loose aid ballasted system, and then for the installations, um, we must consult with roofing manufacturer for the approval types of slab installation details and any internal and moisture insulation. Next, we have the one of the example video of the roof member waterproof insulation installation. And then for the member roofing slope, it must be sloped at least 1 centimeter per foot to transport rainwater to the roof drains by adjusting the height of the beams that support the roof deck, placing a tapered fill of insulating lightweight concrete over the roof deck, or installing tapered panels of rigid foam insulation over the roof deck. So there are different level or different slopes. We have a flat slope, low slope, common slope, steep slope, and also extreme slope. So basically, um, concrete roof system use flat slope, but it depends on the requirement of the building whether they want to use flat slope or steep slope. Next, we have the edge of roof slab. For reinforced concrete roof slabs construction, the edge of a concrete roof slab may be treated in three different ways. The first one is upturned edge beam, overhang, and the last one is for the support of non-bearing curtain wall. The first one is the upturned edge beam. It can form as a parapet wall, and then we have a metal rig that may be cast into the parapet to receive cap flashing. Next, we have the cantilevered. So the slab can be cantilevered beyond its perimeter to support to form an overhang. And the last one is the support non-bearing curtain wall. It is an edge or spandrel beam that can support a non-bearing curtain wall. We also have the metal anchors may be cast into the spandrel beam to secure the curtain wall panels.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Imam Farhan bin Muhammad Fairuz. Now I'm going to talk about roof forms for reinforced concrete roof slabs. This is my overview. First, we are going to explore folded plate structure, and the second one is dome structure, and the last one finally is shell structure. Folded plate structures is an assembly of flat plates or slabs inclined in a different direction. Is it as if it's going in a zigzag rhythm, joined along their longitudinal edges? Modern folded plate structures are typically made of cast in situ or precast reinforced concrete, and it can provide a multitude of shapes and overall forms. So we have three here, which are prismatic, pyramidal, and prismoidal. So prismatic is the rectangular plates, and then the pyramidal is non-rectangular plates or pyramid, and then prismoidal or triangular or trapezoid plates. Such rail system is capable of carrying loads without the need for additional supporting beams along mutual edges. Each plan or the flat surface here is called plan, act as a beam in longitudinal direction. There, this one. And then transverse strips behave as a continuous beam supported at fold points. This one. This is the transverse strips. And then the vertical diaphragms or rigid frames stiffen a folded plate against deformation of the fold profile. This is the vertical diaphragms. And we can conclude that stiffness of the cross sections enables folded plates to span relatively long distances. And now we jump into dome structures. Is a spherical surface structure having a circular plan and constructed of stacked block and circular rigid material like reinforced concrete. Similar to rotated arc, except that circumferential forces are developed, compressive near the crown and tensile in the lower portion. Now we're going more detail about the forces in dome. We have meridional forces, hook forces, and the transition from compressive hook forces and tensile hook forces. Meridional forces are always compressive under full vertical loading. This hook forces restraining the out-of-plane movement of the meridional strips in the shell of a dome. It's going different way from the meridional. It compressive in the upper zone, tensile in the lower zone. Transition from compressive hook forces and tensile hook forces. Here it is around 45 and 60 degrees. And then we have tension ring. Tension ring encircles the base of a dome to contain the outward components of the meridional forces. Ring is thickened and reinforced in a concrete dome to handle the bending stresses caused by the differing elastic deformation of the ring shell. Types of reinforcement of domes. So we have three here, and they are Schwettler domes, lattice domes, and geodesic domes. First, Schwettler domes is they follow the line of latitude and longitude, and a third set of diagonals completing the triangulations. And then we have lattice domes. Follow the circles of latitude and two sets of diagonal forming a series of isosceles triangles. So the difference here are the difference between Schwettler and lattice here are Schwettler used diagonals, just one diagonals, and lattice uses two diagonals, which forms um, isosceles triangles. And now we have geodesic domes. We follow three principal sets of great circle intersecting at 60-degree series of equilateral triangles, basically. Okay, now we jump on to the shell structures. Shell structures is thin, curved plate structures typically constructed of reinforced concrete. It is shaped to transmit applied forces by membrane stresses. They are compressive, tensile, and shear stresses acting on the plane of their surfaces. It also can sustain relatively large forces if only uniformly applied. Because of its thinness, it has little bending resistance, and because of that, it is unsuitable for concentrated loads. And here we have three pictures of the great examples of what we can do with this shell structures method with reinforced concrete. So this is the process of how we are going to create shell structures, the roof so uniquely like these three pictures here. So it started with barrel. It is a cylindrical shell structures. If lying is 3 times the transverse span, it behaves as a deep beam with a curved section spanning in the longitudinal direction. So this, if relatively short, it is as an arc-like action. Tie rods or transverse rigid here frames are required to counteract the outward thrust of the arcing action. And then the translational surfaces. Translational surfaces is a process of parallel to this parabolic or hyperbolic paraboloid. So translational surfaces means generated by sliding a plane curve along or straight line or over another plane. Hyperbolic paraboloid here is a surface generated by sliding a parabola with downward curvature or straight line segment with its end on two skew lines. And then we have saddle surfaces. They have an upward curvature in one direction. Regions of downward curvature behave as a cable structure. If of the surfaces are not supported by anything, by the roof, it might put beam behavior.
My name is Fatin and I'm going to present about the precast concrete roof systems. So precast concrete is a form of concrete that is prepared, cast, and cured inside, usually in a controlled factory environment using reusable molds. Precast concrete slabs, beams, and structural tees are one-way spanning units. The precast units are manufactured with normal density or structural lightweight concrete and pre-stressed for greater structural efficiency, which results in less depth, reduced weight, and also longer spans. So this is the precast concrete units. The precast concrete elements can be joined together to other elements to form a complete structure. So we have the precast slabs and also the precast beams and girders. So moving on, we have the first one is we have the solid flat slabs, which is the typical width is about 4 inches, and then we have the hollow core slabs, um, which have the holes in the middle, and this is the sizes which with a span range about 2.6 to 12 meters. And then we have the single tees with span range about 9 to 36 meters. And then we have the double tees with a span range about 9 to 30 meters. And then we have the rectangular beams with a span range from 4.5 to 22 meters. Also the same span range with the L-shaped beams and also inverted T-beams. And we also have H2 girders. H2 stands for American Association of State Highway and Transportation Officials. The girders is designed originally for bridges structures, but sometimes used in buildings construction.
Assalamualaikum warahmatullahi wabarakatuh. So I'm going to present about bearing connection. So my name is Muslim Muhammad Rasik. My meter number is 2016 391. Okay, note. Precast concrete roof system are similar in form and construction to precast floor systems and use the same types of slabs in it. So at the picture, the top of it is the roofing membrane of a grid insulation, and the above it is the side cast concrete topping reinforced with welded wire fabric or reinforcing bars bonds to the precast slabs to form a composite structural unit. 5 cm minimum of thickness. The topping may be omitted if rigid foam insulation is laid over smooth surfaced precast unit. At your left hand side, here is the bearing. The bearing connection should allow for limited horizontal movement due to creep with shrinkage and temperature changes. And the bottom is to serve as a horizontal diaphragm and transfer lateral forces to shear walls. Steel reinforcement must tie the precast slab units to each other over their supports and at their end bearings. Bearing wall. Okay, precast hollow core slab units is located at the top of it, and below it is the extend steel dowels into reinforced concrete topping or into grouted shear case for structural continuity. Okay, next, grout voids at ends of hollow core units, and in the middle of the bearing with the hollow core units is the high density plastic bearing strips. Minimum bearing length should be at least 1 per 180 of the clear span, but not less than 5 cm for solid or hollow core slabs. Next is the first one is the weld between the wall and precast structural T. Next is synthetic rubber bearing pad to connect with the bearing with the structural T. Minimum bearing length should be at least 1 per 180 of the clear span, but not less than 7.5 cm for beams or stamped members. And wall. Okay, at the top is the reinforced concrete topping with the 5 cm minimum of thickness. At the below it is hooked bars cast into slab edge slots, which is 10 cm. And the bottom is the underside of precast slabs may be caulked and painted. The ceiling finish may also be applied to or be suspended from slab. Okay, next, the top of it is a reinforced concrete topping bonds T units together. In the middle is the solid fill glazed opening, and last one is the reinforced concrete or masonry wall.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Frazim, and I will present about additional bearing connection. So the problem faced in precast concrete slab is, firstly, floor slab essentially consists of a compression joint in the bearing surface. The bearing length should be at least 75 mm to avoid the spalling. So the problem faced is mostly spalling in the precast concrete slab. So firstly, the connection in hollow core slab is the problem with hollow core slab is that there is no projecting reinforcement in the slab, so it requires a frictional tie. So the first step to connect hollow core slab with the beam is set hollow core slab on bearing pad on precast beam. Next, it ready to receive sidebars which are projecting from the beam. After that, the joint grouted solid, and so lastly the gap at the end of the slab and the beam filled by concrete. So the connection in double T slab is the tie force in the double T slab is provided in the temporary situation by welding two plates together. It prevents the beam and the slab splitting during the in-situ concrete screeding operation. So the step in doing the double T slab is, firstly, a rubber bearing is placed at the support point. Next, when the slab is in position, a welded connection is made. Then the reinforcement is placed onto the top of the slab as it should lap with the projecting bars. And lastly, in situ concrete is poured.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hamina and my metric number is 2016022 and I will present to you the concrete parapet under the roof flashing topic. So let us first know what is flashing. Flashing refers to thin continuous pieces of sheet metal or other impervious material installed to prevent the passage of water into a structure from a joint or angle. You can see from the right picture where there's metal sheeting at the roof that is actually functioned to prevent water or rain to enter the structural elements inside the buildings. So the most common material used for flashing are aluminium, copper, and stainless steel. So this material is actually chosen based on the climate and structural requirements. So, so there's a lot of flashing needed in a building. So, for example, at the roof, like I mentioned before, and the roof penetration, such as chimneys, roof drains, vent pipes, and skylights. Windows and door openings also needed flashing. Floors and wall intersections, intersection between roofs and vertical surfaces, the places where the building meets the ground, and also expansion joints and other breaks in the building skin. So let's move on to concrete parapet. So from the picture on the right side, you can see the neon green arrow pointed at this side at the side of the roof, and that is actually the roof concrete parapet. So the concrete parapet is the extension of wall at the edge of the roof, terrace, balcony, and other structures. So the function of this uh, construction method is actually to prevent from fire spreading, and also for safety measures because it can prevent people from doing things like jumping off the roof and to prevent any other things happening such as the falling down or any other things like that. So that is one of the reasons why concrete parapet is done. And for the fire safety measure is that it can prevent spreading of fire, especially at the terrace houses where roof concrete parapet at the roof can prevent the fire as the wooden trusses is not connected to the concrete parapet, so the fire will stop right there and will not spread. So for this is the cross section of the concrete parapet, where you can see that there's a flashing at the base, where this is the flashing at the base, and the other elements such as cap or counter flashing is functioned to make the water droplets and the rings to move uh, downward, follows the gravity, and also to prevent the staining at the parapet wall. So the advantages and disadvantages of parapet roof. So like I mentioned before, the advantages is fire protection, where a house parapet roof burns only one room. The wooden trusses are not linked, so fire will not pass through the parapet. So, and the second one is windbreak. So roof covering on buildings with parapet roofs are not easily blown away. So it is better to have roof parapet on a windy climate. So for the disadvantages, if the parapet walls are not properly built or maintained, the roof will leak. So for the second one, it is costly because the extension of doing this parapet wall causes is expensive, and it is also a high level of expertise is required. So sometimes people do this parapet roof as a design, So it is quite costly for some buildings, and it is needed um, a high level of expertise. So that is also one of the reasons why it is costly. So I think that is all for me. Thank you so much.